So moving on, we have a section on exponential functions, which we've worked with a little bit, but we'll expand on in this video. So to cover a few basics to get us started, the general form for an exponential function is y equals a times b to the x. One of the formulas, or the only formula that we've used this year, is a of t equals a sub 0. This should look familiar by now. This is an exponential function, right? Because it's a times b to a variable, which in the old formula was t. In general, we just say it's x. We'll talk about two different types of exponential functions. Exponential growth, which is on this slide. B is greater than 1 is a thing you need to keep in mind. And exponential decay is on the next slide. We'll talk more about the graphs in class tomorrow or in another video. So this slide here is almost identical to the last one. We've changed to exponential decay. The difference here is your b value is from 0 to 1. So it'll always be positive, it'll always be greater than 0. If it's in between 0 and 1, or it's a fraction, it's exponential decay. And if it's greater than 1, it's growth. So an example like this is pretty straightforward. It just says determine whether each equation models exponential growth or decay. So all we're looking at are these b values and trying to figure out if they're greater or less than 1. Obviously in this first example, 0.8 is less than 1. What we can think of in this parentheses, since it's decay, it's 1 minus r, and we know our factor is 0.8. So the r value, that's really our decay factor and what we're trying to find in the second part of this question. So your r here is going to be 0.2 or 20%. However you want to write it is fine, but that's how you find the factor after. So for this second example, we're looking at 5/4. That's greater than 1, so we know we're dealing with growth. In this case, 1 plus r is going to equal 5/4. So our r value is 1/4 or 0.25 or 25%. Again, a couple different ways you can write this, but that's how you find a growth or decay factor. You're just looking for r. Here's the type of problem that you'll see a lot of, would be a good quiz question. So essentially you're given 2 points, and those points are given to you here. We'll talk about how you extract points from that information. You want to find an exponential function, so we're going to write a formula, and then answer a follow-up question trying to find an actual value. So if we think about some algebra that you learned in the past, if f of x equals y, we know f of x is just another way that you can write y. If I have f of 0 equals 3, that means I have a point at 0, 3, because it's x comma y. The other point I have from this example is 2 comma 12. In setting up a system of equations, in this case, we know y equals a times b to the x is our general formula for this. So I'm going to do that for both of these. I have an x and y here, and another x and y here. So for two separate equations, we have 3 equals a times b to the 0, and 12 equals a times b to the second. Now in this top example, we know that b to the 0 equals 1, so that essentially disappears, and then we know that a can equal 3. That's helpful to plug into our second example, and then we'll be able to solve. So 12 now equals 3 times b to the second. This happened on the quiz. Some of you tried to take a square root too early. You want to divide by 3 here and say 4 equals b squared, and then our b value equals 2. So for these, as long as you have the f of 0 value, if you remember, I took notes on the first couple slides, your y-intercept for these is always 0 comma a. So the fact that we had a 0.03, that gives you the y-intercept and the a value, since they're the same thing. So you can technically skip this step, but you'll get better at that as we do some more examples. So to write my final answer here, I have my a value and I have my b value. We know we need to write something in the form of a times b to the x. I'm going to leave x and y as they are. So y equals 3 times 2 to the x is our final answer. Now the last thing you would do here, and I'm running out of room a little bit, I want to find f of negative 2. That's part B for this question. So to do that, I'm just going to plug in negative 2 for x. So if I do that, I do 3 times 2 to the negative second. I'll do some algebra in my head. 2 to the negative second is 1/4. So my value here for f of negative 2 is 3/4. And again, you'll see, I think there's 4 of these on the worksheet, and these are usually a good quiz question for this section. So here's your second key formula from this chapter. It's another type of exponential. So we're dealing all with exponential functions, but they'll look a little bit different. This may look familiar from last year. I think every class did this, level 1, level 2, all teachers. So a sub 0 and t are the exact same thing. A sub 0 is still the initial amount. T is still your overall time. It's b and k that we need to talk about. So b is what's happening or what's being done to the amount. If you have money that's doubling, your b is 2 because the doubling factor is 2. If you have an isotope that has a half-life of something, the factor is a half because it's being cut in half every so often. Now, the k is the time it takes for b to happen. Since b and k are directly related, think BK, Burger King, believe it or not, it will help. So b and k go together. So if we take a look at just this first line down here, just this first line here, a population of bacteria doubles every 4 days. Well, the doubling, that's your key word. So in this case, that's going to be your b value would be 2. And since it doubles every 4 days and b and k go together, your k value would be 4 there. And we could go through the other two examples, but they're going to follow the same way. In this one, your key word is half-life. Your b would be a half. And for tripling, your b would be 3. One other thing you may want to take note of and write down, be sure that t and k have the same units. So hours and hours, minutes and minutes. You might have to do some converting. We throw in a lot of questions like that where they'll have different units and you'll have to convert before you can solve. So we'll try a couple quick examples and we'll call it a video after that. This problem says a population of bacteria doubles every 4 days. So our key word here is doubles. If we start with 4,000 millimeters of bacteria, how much will be left after 18 hours? So in this case, as we start to fill this in, we have A of t equals A sub 0, or our initial amount, is 4,000 millimeters. Our B value, since we're doubling, is 2. I usually do B and K back to back since they go together. Since it doubles every 4 days, I'm going to put a 4 in for K right away, so I don't mix the two up. The T and the K are people mix up all the time. So T in this case, it's asking us for 18 hours, but we'll notice already that we already have a problem with units. 4 days and 18 hours are in different units. So as we try to figure that out, I'm going to convert 18 hours to days, so that's 3/4 of a day. So this is really going to be 3/4 over 4. If you're careful with parentheses, you could enter that into your calculator. You could also simplify first and rewrite it as 4,000 times 2 to the 3 over 16. And when you plug that into your calculator, I'm going to round to the nearest bacteria here. We end up with 4,555 millimeters. And that would be your final answer. So again, the biggest thing to be careful of is making sure you have T and K straight and checking your units. For our last example, the half-life, there's your key word, of carbon-8 is 13 seconds. So B and K are going to go together. B is going to come from a half. K is going to come from 13 seconds. If we start with 220 milligrams of carbonate, how much will remain after 1 minute? So again, we have differing units. We have seconds and minutes. An easy conversion, just make sure you catch it. So our formula again isn't changing. A sub 0, B to the T over K. As we start to plug in, A sub 0 is 220 milligrams. Our factor in this case is 1/2 since it's a half-life. We'll see a lot of half-life problems in this section. B and K go together. We said our K was 13 seconds. And we want to know how much is remaining after 1 minute. So our T value will be 60 seconds. So we'll make sure we have the same units. It doesn't matter whether you use minutes or seconds or which unit you pick, as long as they're the same. Which way you convert doesn't matter. When you're plugging this into your calculator, make sure you put the 60 over 13 in parentheses. That'll mess you up a little bit too. For this example, we're going to get 23.83 repeating. And the units there is milligrams. So that would be your final answer for that one.